execute the exact same steps as we did yesterday with the exception of the very end. You may notice as you flip through today's note sheet that it's not plus signs in between your two rational expressions. Today we're going to subtract rational expressions. And you folks know that whether you add or subtract fractions, your denominators need to be the same. So as I look at this first example, right now I notice, the denominators aren't the same. So step 1 and 2, those first two steps are the work that you do to get the denominators to be the same. So I'm going to go ahead and step 1, I'm going to factor the polynomials in the denominators completely. So do you see x squared plus x? I'm going to take the x out and leave it as x plus 1 in the parentheses. So I factored out a GCF there. And then x squared plus 2x plus 1, there's no GCF, so I'm thinking about the factors of 1 that make 2. That is x plus 1 times x plus 1. So now I can use these factored denominators to identify my least common denominator. I bring down the factors on the left, and then I compare them with the factors that are written on the right. What's missing? Another x plus 1. Very good. So that is my least common denominator. As I was walking around the room, this is the step, as I was checking your homework from last night, this is the step that most of you were omitting. After you find your common denominator, you need to do something with it. You need to rewrite your fractions so that they have this common denominator in them. So I always start that process by just rewriting the original problem with my factored denominators. So this fraction, first fraction there, is 3 over x times x plus 1. Bring down my minus, and my second fraction is x plus 4 over x plus 1 times x plus 1. I then look at those fractions, I'm like, oh, my denominators are not the same, so I can't subtract yet. I need to modify the denominator so that it is actually my least common denominator. So I'm going to fix up each of these rational expressions so that they have my LCD in them. So if you take a look at this first denominator here and compare it with your LCD, what's missing? Yeah, another factor of x plus 1. Very good. What you do to the bottom of a fraction, you must always do to the top. If I look at my second rational expression, look at the denominator right there, I notice I'm missing something from this denominator in order so that it is the LCD. What's missing? X. Very good. I can't quite yet subtract. It'd be nice, but I can't. Because I need some terms. Eddie, you do have to distribute. Very good. So I'm going to go ahead and do that. I'm going to distribute the 3, and then I'm going to distribute the x into the x plus 4 to multiply those together. So when I distribute the 3 into the first part, I get 3x plus 3, and then that's over my LCD, x times x plus 1 times x plus 1, which is the same, by the way, as x plus 1 squared. Yep. Bring down the minus from my original problem. And then I'm going to distribute the x in, so this will be x squared plus 4x over x times x plus 1 quantity squared. There. And then I'm asked to identify the difference between these two rational expressions. We never subtract, really, polynomials. I find that if I teach it as subtraction, I see a lot of sign mistakes. Instead of subtracting our fractions, here's the phrase you need to remember. We're going to add the opposite. We're going to add the opposite. So this minus sign right here, I'm going to turn that into a plus. That's me taking care of adding. And then I need to identify the opposite of the entire second numerator. So the opposite of x squared is negative x squared. The opposite of 4x is negative 4x. And then it's just like last night's homework. You add straight across the top. I always start with my degree holding term or my highest exponent. So my degree holding term is this negative x squared right here. So I'll write that first. And then next in line would be 3x and negative 4x. That's negative 1x plus 3. What's up? Sure? Why would you change the sign for x? Yeah, I had to make them both negative. Oh, good question. So over here, why do I not? Okay, for this reason, Ed. If I ask you to do 3 minus 2, that's 1, right? We can actually define subtraction as adding the opposite value. For instance, 3 plus a negative 2 is also 1. Notice I only changed the sign of the second value, not the first. So it just goes by our definition for subtraction as adding the opposite of the second thing. So that's why I didn't change the sign on the first ratio. So it's only the second fraction you change. Okay, now it's over my LCD. Okay. As you take a look at your problem, you always want to make sure it's in factored form. If you tried to AC group that trinomial on top, it does not factor. So this is done. The end of this one. Let's try one more, and then you're going to have your independent practice. I got to start by factoring my denominators. So that's what I did there. I then use my factor denominators to identify the LCD. So I'm going to bring down x minus 6 and x minus 1. And then do you see what's missing? What I didn't write yet? Good. That's my LCD. I then rewrite my problem. Just extending my fraction bar a little bit. So this is my original problem right now with the factor denominators. And then I just insert any factors that I need in order to make my denominators the same. Make my denominators the common denominator. So this guy here is missing a factor of x plus 4. What you do to the bottom of a fraction, you always do to the top. Same thing over here. X minus 6x plus 4 is missing a factor of x minus 1. And what you do to the bottom, you always do to the top. Now the denominators are the same, so that's nice. They're both a common denominator. So now I just need those terms. I need to distribute and FOIL. In this case, it's just the distributive property. I just need to distribute through the top so that I can get those terms to subtract. So x times x is x squared. X times 4 is 4x. And that's all over my LCD. And then my second ratio, if I distribute that x through, I got x squared minus x all over x minus 6, x plus 4, and x minus 1. And this is the only step that's changing from yesterday. Remember, we never subtract. You always add the opposite of the second numerator. So I add the opposite of my second numerator. So I change my minus to a plus. The opposite of positive x squared is negative x squared. The opposite of negative x is positive x. And now I can just add straight across the top. X squared and negative x squared, those go away. So I have 4x plus 1x, that's just 5x over my LCD. And that is done. So now you get to try one all by yourself. I'll show you the answer in just a moment. There's your answer to your independent practice. You have book work tonight, FYI. Have a nice weekend.